So hey guys, this is Miyas, and in this video we are going to solve the day 10 binary numbers problem that is present on the HackerRank in the 30 days of code. Okay, so in this problem we are going to deal with the binary numbers. Okay, and before we can start solving this problem, please let me give you another suggestion that please watch this video from beginning to the end, because if you face this same problem in the future as well, then you can easily solve that problem as well. Because if you didn't understand the problem and the scenario around this, then you not able to, or you will not able to solve this kind of particular problem in the future as well. Okay, so if you are facing these such kind of problems in now time, then you are definitely facing these kinds of problems in the future as well, because you are dealing with the coding part. Okay, so in this problem we have given a base 10 number. Just like you can see, we have given the base 10 number integer, and we need to convert it into the binary number. Okay, and then what we need to do is we need to find and print the base 10 integer denoting the maximum number of consecutive ones in the binary representation. Okay, so what we need to do is, let's say we have given 125, that is the base 10 number. Okay, and what is the base 10 number? That is divided by the 10. Okay, so 125 is successfully divided by 10, that is come around 12.2, 12.5. okay, so it is a base 10 number. Okay, so if we are converting base 10 125 into the base 2, then it will come 1111101. okay, and what we need to do is we need to take for that if there is any continuous ones present in the base 2 number. Let's say we have 1 2 3 4 5, and 5 times 1 occurring in the base 2 number of base 10 25, and then we have another one, but that is separated with the 0. okay, so that is not the continuous one. Okay, so what we need to do is we need to return the maximum number of consecutive ones occurring in the base 2 number of 125. okay, so let's we have the 1 2 3 4 and 5, so we are going to return the 5. okay, and if you didn't understand, then there is a sample input as well. Let's say we have get the 5 input from the user. okay, and we are going to return the 1. Why? Because base 10 number of the 5 is 5, and base 2 number of 5 is 101, and what is the maximum number of consecutive means the continue occurrence of ones. okay, so here we have 101, so 1 is only occurring for one time, and another time 1 is occurring for the one time. okay, so we are going to return the 1. okay, in the another sample case we have the 13, and the base 2 number of 13 is 1101, and in the base 2 number the ones are occurring for 2 times, and then ones is occurring for only one time. okay, so we are going to return the maximum value out of it. So 1 is occurring for 2 times, and here 1 is occurring for one time, so we are going to return the 2. okay, so here is the my solution as well. So I'm going to do this in the Python 3. So first of all, we are going to take from input from the user. okay, and this is because the Python is a 3 version, so we are going to convert it into the integer part. okay, and then we are going to store in the integer variable n. okay, and then we are going to initialize a list here. okay, so whenever we get the binary numbers, we are going to store the value of the n into this binary in this list. okay, so we are going to first convert this n into the binary number. okay, so while the value of the n is greater than 0, we are going to percent by the 2, and then we are going to take it from the rm, and we are going to append it into the rmd, and that is the list. okay, and let's take an example to understand and easily understand this. Let's say we have the number 5. okay, so this is greater than 0, so we are going to take rm is equals to the 5% 2, that is going to be 1. okay, and what is going to be n is equals to the 5/2, that is going to be the 2.5, and that is going to be 2. Why? Because we have the double slash here. Okay, so this will give us the whole number. Okay, so if we have the floating point here 2.5, then it will return the only 2. Okay, now it will return it will append this 1 into the RMD. Okay, so we have the 1 here. Okay, now the value of the n is equals to the 2. Okay, so RM is equals to the 2% 2, that is going to be 0. Okay, n is equals to the n slash slash, and that is mean by at 2 slash slash 2, and we are going to the 1. Okay, so we are going to append the 0 into this. Okay, we are going to just append this, let's say, and then we are going to take n is equals to the 1. Here n is equals to the 1 because we have the double slash here. Okay, and then we have the RM is equals to the 1% 2 equals to the 1. Okay, and then n is equals to the 1 slash 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 2, that is going to be the 0.5. okay, and sorry, this is not the 0.5, it is going to be 0. Okay, and then we have RMD, that is going to be append the value of RM, that is going to be 1. Okay, so we have the 1 0 and 1 here. Okay, so this is the binary representation of 5 number. Okay, so let me erase this out. So we have the binary number here. Okay, and then we are going to take two variables, count result, and that is going to be into the equals to the 0 0, and then we are going to run the for loop as well. Okay, why we are going to run this for loop? Because it is going to be 0 to length of RMD, that is going to be, sorry, RMD. Okay, so we have the 1 0 and 1 here. Okay, so we are going to run from 0 to the value of the last value of the RMD. Okay, so it will run from 0 to the n-1 index. Okay, that is the length of RMD. Okay, so if the value of the RMD I, that is going to be the first index, is equals to the 0, then we are going to take the count equals to the 0, because if we have occurring for any time there is any 0 present here, then we are going to count to the 0. Okay, and if not, then we are going to count to the +1. Okay, that is going to be the max of result comma count. Okay, so let's say we have the 1 here, so count will take as a count equals to the 1. Okay, and then what is the value of the result is equals to the 0 comma 1. So what is the max value of this function is equals to the 1 here. Okay, so it will return 1 here. Okay, so that's it. Now I think you can easily understand this logic, because here we are just going to take the value of the n, then we are going to initialize our list here, and this list is going to be append some values of binary numbers from the n. Okay, and then we are going to run a while loop to get the binary number from the n. Okay, and then we are going to take for the two variables count and result is equals to the 0 comma 0. Okay, and then we are going to take for the for loop. Okay, so this for loop is going to be take for, like, if we have just like we have the 1101, then it will going to count the maximum number of consecutive ones are occurring in this binary number. Okay, so let's say we have 1101, so here we are taking from 0 to the length of this list here. Okay, so we are going to, if the value of the RMD means the first index is equals to the 0, then we are going to take for the count is equals to the 0, and if not means the 1 is occurring for multiple times here. Okay, so it will take 1, and then 1 means the value of the count is equal to the 2 and the result is equal to the 0, so it will take the max out of result and count, then it will store into the result. Okay, and another time if the value of the if the value of the count is greater than result, then it will also take the max value and it will store into the result part as well. Okay, and then we are going to print the value of the result. Okay, so that's it. This is just a simple logic. We are going to run this code, and now we have successfully submitted the code, and that's it. This is just a simple problem. If you have basic understanding of how we can convert the base 10 to the base 2 numbers using the coding part, okay, and using the while loop, then you can easily do this problem, okay, and easily solve this problem. Okay, so that's it for this video. We'll be meeting you very soon with another problem and another solution as well, and with the explanation as well. Okay, so bye bye and see you again.